All right, so let's now look at an example where I can point out how to apply our understanding of the definite integral into the field of business and economic studies. Okay, so this is only one of the applications, one among the applications of the definite integral, of bringing the definite integral into the business and the economic studies. There are plenty of those applications out there, and so I will bring up if I can, okay, within my capability, I will deliver as many separate videos for different applications as possible. So keep checking back with my channel on that, with my videos on all the applications of business, of the definite integral on business field or economic studies. Okay, and so before we really are heading out to that to the application that I'm about to bring up right now, let's have a look again at the fundamental theorem of calculus that we have studied. And of course, I'm not going to have to copy down the whole wording of that, but let's just focus only on the essential part that was as following. So the main part is when we're taking a definite integral on any function in respect to x, and it's an integral over the interval from a to b. And so this fundamental theorem of calculus says that, guarantees for us that the outcome of this, the final answer of this, can simply be done by taking the antiderivative and then substitute the value of the upper limit into the antiderivative there, and then we're going to take the difference with the antiderivative evaluated at a, the lower end of our integral here. And so of course it's just a quick reminder. So f here is related with lowercase f. The capital F is related with lowercase f through this relationship. That's capital F prime will equal lowercase f of x, or this is the perfect way of explaining this is capital F is the antiderivative of our original function that we are integrating here, that we're taking the definite integral. So assuming anyone is knowing this, so I'm going to take that piece of information away, because I want anyone viewing this video to have a real good close focus here. So we already I just now erased that line. Capital F and F in our original integral problem is the relationship by the function, and it comes to antiderivative. Or if this is the function, and then that's the derivative. Lowercase f is the derivative of capital F. They're just sort of like the reversed relationship of each other. Okay. And further, I want to emphasize that if we're looking at the and here, it's a difference. And difference in math, we use a difference to represent, to calculate a change. To calculate a change. And so this difference here, in another way of understanding that, think about once we have arrived from a derivative to the original function. So this is derivative, lowercase f of x, you can think of that as a derivative, and so we are taking the antiderivative, landing us back into the antiderivative version, and then the definite integral is proven to be just simply, so this difference here is just the change, or in some case we can just call it the total change. It's a change in the value of f, okay, as the x value changes from a to b. That's another way I want to drive my viewers, my students, into that understanding. We don't want to just simply take this as a formula, and yes, we already enjoyed the usefulness of the fundamental theorem of calculus, but now having a closer look into that, this difference here is to indicate it's a total change. The change in what? The change in the values. The change in the values of f, of capital F of x, as the x variable changes from a to b. Okay, so keep that concept emphasized and highlighted there for me. Okay, because now specifically when I'm about to drive this understanding into business concepts there, let's quickly review a couple following. The marginals. Okay, so if we're looking at the cost function as a function capital C of x, okay, anyone learning business doesn't even have to be in a business calculus course, but anyone studying business or taking a math course for business, you are well familiar with this capital C function. It's a tradition to use a capital C for the total cost. And so total cost here has, so if this is total cost, okay, or just cost function, or total cost. Maybe let me revise the naming of that a little bit. Okay, for short it's just cost, but total cost function. And then as a name we call that it's a capital C. And x here, most of the time we assume our x here is to be the variable in terms of quantity. And so for total cost we have the corresponding version, and at this point when you arrive at this, then you must have gone through the learning about derivatives of these fundamental functions. So the derivative of total cost function is, now we have a name for that. So C prime of x, we call that, it's the marginal cost. Nothing should be a surprise about this. Okay, and so in that way, similarly, if we're looking at the total revenue, okay, total revenue, these fundamental quantity in business that anyone who's studying business math with me has been hearing me emphasizing a lot with these three fundamental quantities right there: the cost, the revenue, that's for selling out, the cost for producing X units, and the revenue we're making for selling out X units. And then, so corresponding to the revenue function, then we knew about the marginal revenue. Okay, and so marginal revenue, up to this point of our understanding, it's the derivative of R. And then now I also need to mention there are quite a few different variations of these symbols out there. Marginal cost can also, throughout many textbooks, or even in some of my examples, I use the MC for marginal cost with a bar on top. That's the function. Or some textbooks use this MC with X. There are so many variations out there. So when you're actually doing, and this is a good recommendation for any of the viewers or even my students, that when you are working with a problem that works on the marginals in general, then watch for there has to be a definition somewhere here and there about the naming, the labeling convention of your quantities here. So just like that, R prime is the primary symbol for marginal revenue, but quite a few textbooks use MR with a bar. That's for the marginal revenue as a function, because R prime of X is a function. And then there's an MR with in parentheses X. That's another form commonly seen enough. So these are all different ways of how we express marginal revenue function. And then we studied, and as I keep saying, these quantities didn't have to wait until your calculus learning, and you even learn that long before you enter a business math course right here. So total profit function. Okay, so total profit function, very commonly named as a capital P of X. Okay, and so now the corresponding marginal of that is called the marginal profit. And so now here I don't have to explain what a marginal profit is, what a marginal revenue is, what a marginal cost is, and because I assume any of you viewing this video has already learned from your past about what these marginals are. So here I'm just reminding. And so, yes, directly speaking, it's P prime. Okay, or many textbooks use MP with a bar, or even some MP X. So that's these are just some reminders about the marginals that we've learned. Okay, so why do I mention this? Okay, so now, how do we see all this in the concept of a definite integral? So I have explained this fundamental theorem of calculus hopefully detailed enough now. I'm going to need to erase that to make space here. So here's what we can, this is how we can start bringing our understanding regarding the fundamental theorem of calculus into any of the marginals I have mentioned. Think about this. A lot of time, I have also mentioned about this in some of my other applications video lessons earlier. But a lot of time we actually, it's easier that we actually know the rate of change. Okay? All of these marginals, they are in another way of saying they are the rate of changes, the instantaneous rate of change. Derivative of c, the derivative of cost, that's the instantaneous rate of change of cost. At some instance where x is this particular number of units, or at x is another particular instance being a different particular number of units, and then the same here for marginal revenue and the same for marginal profits. These are all instantaneous rate of change. Okay, and so back to what I was in the middle of saying, a lot of time we actually, and surprisingly, it's easier for us to know the rate of change, the instantaneous rate of change. And then from there, we're going to start doing the kind of problem as following. So let's say on our marginal cost, it's an instantaneous rate of change of cost. But now if we're seeing that simply as a, how about I should have made my choice of using the C prime right there. So C prime, yes, it's the derivative of the cost function, but if we're now looking at C prime as one function on its own, the marginal cost function, and now if we applied the definite integral, we take the definite integral of C prime right here over an interval of value, so these are all supposedly the units, okay, from x equals a units to x equals b units. So think about this. If we take the definite integral on top of a marginal cost function, then straight out of the math, according to the fundamental theorem of calculus, then so if this is the derivative, then what is the antiderivative version of the C prime? Think about that. It has to be just C, no prime, because this is the antiderivative of C prime. And so now, according to the fundamental theorem of calculus, we're just going to take the antiderivative, which is now becoming just the capital C, no prime. And then further, the fundamental theorem of calculus say we're going to take the antiderivative and evaluate that at the upper end of the interval, of the integral interval, and then minus the antiderivative value at a. So this is straight out from the fundamental theorem of calculus. So what's the impact here? What's the whole reason I point out about that closer look at the fundamental theorem of calculus is that now when we're looking at this, hey, wait a minute, this is now in the actual concept of cost right here, then this difference here is a change. So now we can refer to this as the total change of, or the total change in cost. Okay, it's a total change in cost. Corresponding to or how about, that's not a good way of writing that, the total change in cost as production, because I really try to make people put themselves, make viewers or my students to put themselves in the actual business concept and context like that. So in a business context, we're talking about production level change, right? So as production changes from x equals a to X equals B, from a starting production level to a final production level. And that's what this is. Okay, it's just a total change. But it's not a ratio here. It's just the total change as we change production from X equals A units to a different value, X equals B units. Okay, and so it's now all of a sudden we came to a realization that simply applying our definite integral, or take a definite integral on top of our marginal, this is particularly the marginal cost, then we specifically arrive at the total change in cost as our production changes from A units to B units. So with this generality that we have realized, with this realization, can we also further apply this understanding into the other marginals? The other marginals, mainly on my board here, so if there's marginal revenue corresponding to total revenue, there's marginal profits corresponding to profit function. Can we do the same thing? Oh, sure we can. So now I'm going to swing back to my board again. Now sadly I have to erase this. So hopefully you had enough opportunity to take notes down on that, and or you can always rewind the video here to catch whatever the information you have missed. But so now let's look at the marginal revenue as an R prime. So now we're going to think about what if, or what's the meaning of taking the definite integral on top of that, or of that marginal revenue function in respect to the x variable for quantity. And so, of course, as a straightforward explanation, fundamental theorem of calculus says that the final answer will be simply just R, the antiderivative version of this R prime. Because if this is R prime, R is going to be the antiderivative version of that. And then we're going to evaluate the antiderivative here at B, and then take the difference with the same value of the antiderivative but at A. Okay? There we go. It's a difference again. This difference represents a change. So now again, let's look deeper and put ourselves in the situation where we're running a business. We're making revenue right here. So a subtraction like this, a difference in revenue, means what? And of course, when we're talking about revenue, then it's not production level, but we're talking about selling number of units. I mean the number of units that we can sell away. Okay? And so a difference represents a change. So this here is similar to cost. Now for revenue, R of B minus R of A right here is the total change in revenue. Okay, as sales. Okay, change, or just whatever sale that is. Shouldn't put plural there. As sale changes from selling X units, or I mean selling A units, to selling B units. Okay, so we switch from production level to sale level. Okay, and so but in the end, it's just that we're just circulating around that fundamental that our final answer means a total change of the antiderivative version. And that's why I fundamentally brought up the fundamental theorem of calculus, and to look a little closer in depth. And that's why the fundamental theorem of calculus was named the fundamental theorem of calculus, because from where that is, it's being applied into so many different fields out there. Okay, and so now all of a sudden we realize this. Then again, let's quickly look over to our board. The same is going to happen with the profit here, with the total profits function, namely or symbolically as a capital P of X. The corresponding marginal for that is the P prime, the most primary notation for that, or MP bar, or P of MP of X. So many different variations of the symbols out there. But now the idea fundamentally is that if we are having a marginal profits function and we take an integral, a definite integral on top of that in respect to the x variable, then of course, straight out from the fundamental theorem of calculus, then we know that we're going to land into the antiderivative version of our p prime, which is p. Okay, so we're back to the profit function, and then that's going to be evaluated at b, the upper end of the interval, and then minus capital P of a. It's just straight out as a consequence of the fundamental theorem of calculus. But now again, looking at this difference right here, it means this is the total change in profits. Okay, it's the total change in profits as the number of units sold changes from x equals a to x equals b units. And once again, that's just that exact same fundamental that we keep circulating around with that. All right. But now, surprisingly, once we nail down with this concept, we open for ourselves one big door that handles a lot of problems, because a lot of times in our business work out there, surprisingly, the analysts that we hire to do the work for us, a lot of times it's easier for them to monitor and come up with a function that models marginal cost, a function that models the marginal revenue, a function that models marginal profits. So it's easier for our analysts to come up with those functions. And so for now, for us here as being the employer, once we've had those marginals right here, and all we do is we can just take a definite integral, and that immediately arrives for us as a good, as a final value for us to understand how much change in total revenue or how much change in total cost our company has spent. When we make a change in production level from a number to a different number. Okay, and so now enough talk. Let's really do a problem. So now I'm going to bring up on my screen, and so once we understand the fundamental, in my example, I don't have to go through all three different kinds of marginal and another example for cost, another example for revenue. Nope, that's not the plan. I'm only going to focus on one of these. Okay, so. And then that same generality will be the same for the rest. Okay, so let's see which one is which one of the three main marginals will be brought up in the example I'm about to bring up right here. Okay, so all right, so it looks like the example I have here for everyone is the example on so this MC bar right here is the symbol for marginal cost. Okay, all right, so let's have a minute reading it. If the marginal cost for ski gloves is, so think about we are the one who runs that company. And so we hire some analysts, they come up for us this function right here that's called the marginal cost. So MC bar, as I explained earlier, that's one of the commonly seen enough notation for marginal cost function. And this is a function in terms of x as the units right here. I apologize for a little bit sketchy description of my example right here. But so this function models the instantaneous rate of change of cost at any x units right there. Or yes, formally speaking, that's the marginal cost of that's the marginal cost for our company. Okay, and so now from this modeling function right here, the simple question now is just find the total change in cost for producing x equals 13 to x equals 27 units. So really, I believe there's a missing word right here, but it's supposedly for changing production. So we want to find the total change in cost for changing production from x equals 13 to x equals 27 units. And again, I apologize for such a sketchy description, but that's what it's meant. For producing x equals 13 to x equals 27, that's what it means here, is that there was a change from there was a change in production level from X equals 13 units, and we changed to producing more units, 27 units. Okay, so along that way, we want to find out what's the total change in cost. All right. So now, after hopefully some detailed explanation, because the wording description of my example was a little sketchy. But now, once we understand what our goal is, we want the total change. We want the total change in cost. Okay, for changing production from X equals 13 to X equals 27. And we already had a marginal cost function given. And so now, here's our perfect opportunity to apply what we have just now learned. And so, recall again from what I just explained, and I already erased that, and you can also rewind the video here, but you see the name of that quantity that we're trying to find here is the total change. Okay? It's the total change in cost, or the total change of cost right there for production level change from X equals 13 to X equals 27. It's a starting production level, and we change to a final production level. Okay, and it's the total change. This is what we're looking for: the total change in cost for the production level change from X equals 13 to that. So cost is our famous what? Capital C. And so in the way how it looks here, total change is the difference. Okay, so that means what? C at 27 minus C at 13. Okay, but now with this right here, then, well, now it's becoming a little more clear and a little more clear. Think about we can obtain this through the fundamental theorem of calculus. Then this must have come out from taking our MC as the marginal cost function. It was a function given on the screen previously. Taking the definite integral from 13 to 27, or over that interval from 13 to 27 in respect to x. That's how we can arrive at this answer. Okay, and that's how we can eventually calculate our goal that we're looking for. Okay, and so I have to be clear. The point now is that we only know the marginal function, the marginal cost function, and we don't know this, but this is what we want to find out: the change in total cost, or the total change in cost. Okay, and so that's why in that way. Now let's look back at the problem. Okay, so now there we go. This is our marginal cost function, being 4.5x plus 14.5. All right, so in that way, now the story becomes so clear. We have a starting setup, a definite integral from 13 to 27. Okay, and our marginal cost function there was 4.5x plus 14.5, and now I'm going to take the integral over that interval in respect to x. Okay, and so now the work will become a lot easier. So I'm going to go through the fundamental theorem of calculus steps one by one right here. So first, we're going to take the antiderivative, which is the C function, the total cost function, before substituting in these values. So 4.5 over 2x squared. Okay, and allow me to assume that anyone viewing this current example with me has been fluent with how to find antiderivative. So allow me to move on without too much explanation on each of these antiderivative steps right there. Okay, and then I'm going to add now with the 14.5 over 2x. And actually, I don't need the over 2 right here. 14.5x. And just like how I explained back in my general lecture regarding how to take regarding definite integral, then when we take the antiderivative only as a step before we move on to the final work here in the fundamental theorem of calculus, then we actually don't need to do the plus constants here. Okay, so now fundamental theorem of calculus says from this found antiderivative, I'm going to need to substitute in eventually 27 and 13. Okay, I'm running a little bit out of space here in my board, so I write that in a little in a way that looks a little awkward here. So forgive me on that. But now our calculation is ready. So here we're looking at 4.5 over 2 times the x variable is to be substituted with 27, okay, square plus a 14.5 and multiplying that with 27 again. And all that there, this is, ladies and gentlemen, C at 27. That's a quick note for that. That's what it is. Okay, and then now I'm going to subtract. And now again, there's that 4.5 over 2. And I'm going to substitute in 27. And I'm going to square that difference. I'm going to square that. And actually, it shouldn't be 27 here, but it should be 13 here. Okay, so square the 13. And I'm going to plus with 14.5 times 13 evaluated in. So that's my work right there. Okay, and so this work that I just now complete is C of 13. So that's, now we are ready to obtain and to find that the difference between C of 27 and C13 right there. And this is, in the end, the final answer here will be our total change in cost as production changed from 13 to 27 units right there, because we only started out knowing our marginal cost function. That's a good usefulness of learning about the definite integral right there. I am going to quickly step away for a calculation, and I will be right back. All right, so now I have a final value ready to be displayed on my board here. So viewers and students of mine, you are more than welcome to do your own calculation here with your own preferred calculator. I use a decimal to quickly give me the result here, and so it gave me, so the final change in cost here was a positive $1,463, so $1,463. That's the total change in cost, and we have answered our question. All right, so outside of this example right there, again, if the problem here was instead of MC given here, but given you, if the problem in the beginning was giving you MP or MR instead of MC here, then we're just gonna follow the similar way right here. We would take the definite integral on top of our other marginal function, and then we come up with the actual function. It could be a marginal, it could be a profit, it could be a revenue, and then we do the subtracting out based on the fundamental theorem of calculus again. And then we're going to arrive at the total change, either the total change in revenue or the total change in profits. Okay, as sales units change from a certain units to a different unit. Okay, and that's how we're doing, that's how we can understand how useful that is to take a definite integral on any of our marginals. Not only marginal cost here, my example was on the marginal cost, but it should be applicable to any of the other marginals that anyone has been knowing. Okay, and so generally speaking, we just take on our given marginal, we take the definite integral, we're going to land into the, doing that, it will get us into the total change in either cost or revenue or profits as the production changes or the number of units the sold changes from a unit to a different units, a different number of units. Okay.